Hey everybody, this week we are working on reviewing all three types of solving systems of equations. There are three different ways to do that: graphing, substitution, and elimination, which we worked on the last couple of weeks. So your assignment this week is just going to be one Math Excel over all three. It's going to be like your quiz grade for this unit. So I would make sure you're trying really hard, you're using the help button, and you're asking me if you need anything. So this video is just more examples of how to do what we've been doing the last couple of weeks in case you want to look at some extra examples. So when we're graphing equations, there are two steps we have to follow every time. And that first step is identifying your y-intercept. And then your second step is to identify your slope and use it to plot multiple more points. So for the first one, our y-intercept is positive 2. So we're plotting our point at 0, 2. The slope is a 1. Since there's nothing in front of x, we assume that there's 1, which means we're going to go up 1 over 1, up 1 over 1. And then we can draw our line to connect those. There we go. Our first line is plotted. I'm going to switch colors for my second line. My second line, y-intercept, negative 2. So 0, negative 2. And our slope is 3. So that means we're going to go up 3 over 1, up 3 over 1. And then draw our line. And you can see that they shared a point, so the solution there would be 2, 4. Okay? Then you just repeat those steps every time. So if we look at number 2, y-intercept of the first equation is positive 3, and my slope is 2. So up 2 over 1. Up 2 over 1. And then you can draw your line through there. Same thing with the second equation, positive 1, sorry. Slope of 2, so up 2 over 1, up 2 over 1. Draw your line there. And you should notice that these two lines are parallel, which means there's no solution. They will never cross. Our third example, if you notice, our y-intercept is 4, and our slope is negative 3, so down 3 over 1 this time, down 3 over 1. Then in my second equation, it's not in y-intercept form, so I would switch that by subtracting the 3x from both sides, which would give us y equals 4 minus 3x. And then from here, we can identify our y-intercept is 4, and our slope is negative 3, so down 3 over 1. And you should notice that these lines are perfectly on top of each other, which in my first video on graphing told us that this is an infinite solutions. So there are three different options when solving graphically: a 1 solution, no solution, and infinite. So you need to be able to identify those things. Our second method that we're going to talk about right now is substitution. So with substitution, you need to make sure that it's very similar. We've been doing it like all year. Isolate a variable, substitute what you get in for that variable. So in this situation, we know y and y are isolated. So y equals y, which means we can write negative x minus 6 equals x minus 4. Those things are equal to each other because y's are equal to each other. And then you just solve for x. So I'm going to add x to both sides. Negative 6 equals 2x minus 4. Add the 4. Negative 2 equals 2x. Divide both sides by 2. Negative 1 equals x. And then from there, we substitute that negative 1 into either of our original equations and solve for y. I always just use the first one. So y equals negative x minus 6. Going to substitute negative 1 in. Y equals negative times negative 1 minus 6. A negative times a negative is a positive 1 minus 6, meaning y equals negative 5. So my solution is negative 1, negative 5. Sometimes, though, only one variable will be isolated. So if we notice here, only the first y is isolated, which means we know that this entire value can be substituted in for y, which would look like this over here. X minus the whole quantity, make sure you put it in parentheses, 3x minus 2 equals 4. The reason it needs to be in parentheses is because we need to distribute this negative to both parts. So x minus 3x plus 2 equals 4. Negative times a negative is a positive. X minus 3x is negative 2x. Still plus 2 equals 4. Subtract 2 from both sides. And we have negative 2x equals 2. Divide by negative 2. X equals negative 1. Then from there, again, substitute it into an original. Y equals 3x minus 2. Y equals 3 times negative 1 minus 2. Y equals negative 3 minus 2. Y equals negative 5. So again, I have a solution of negative 1, negative 5. I'm going to do 2 more substitution examples. 3 is really similar to number 1. Both of them have y isolated. So again, you're just going to set the back halves equal to each other. So 2x minus 10 equals 4x minus 8. And then you just solve. So subtracting the 2x from both sides. Negative 10, make sure you bring that negative down with it, equals 2x minus 8. Add 8. Negative 2 equals 2x. Divide 2. Negative 1 equals x. Substitute that negative 1 into one of the originals to solve for y. Y equals negative 2 minus 10. Y equals negative 12. My solution, negative 1, negative 12. Last example using substitution. Again, here we only have one variable isolated, so we're going to substitute this entire piece in for y, which will look like this. 2 times the quantity of negative 2x minus 3 equals 2x plus 12. Again, when we have the parentheses, we need to distribute, so negative 4x minus 6 equals 2x plus 12. Solve for x. This is negative, make sure you watch that. So negative 6 equals 6x plus 12. Subtract 12. Negative 18 equals 6x, divide by 6. Negative 3 equals x. Substitute that in for y. 2y equals 2x plus 12. 2y equals 2 times negative 3 plus 12. 2y equals 6 plus 12. 2y equals 18. Divide both sides by 2. Oops. And y equals 9. So your solution is negative 3, 9. All right. Next was elimination. So elimination is when we want to eliminate a variable. So if we look at our first system, right away, there's nothing that cancels out on its own. But we can multiply our second equation by something so that our x values will cancel out. So since we're not doing anything with the original, or the first equation, I'm going to write 4x plus 3y equals negative 5 over here. But I'm going to multiply the second equation by 2. And you need to make sure when you do that, you are multiplying all three pieces of the equation by 2. So we would get negative 4x plus 4y equals 12. From here, your next step is to determine, am I going to add these two equations together or am I going to subtract them? So since the 4 and the negative 4 are opposites, we have to add. They will cancel. We'll have 7y equals 7. Divide by 7. And y obviously equals 1. Then, just like with substitution, we're substituting that 1 back in for y to solve for x. So 4x plus 3y equals negative 5. Sorry. 4x plus 3 times 1 equals negative 5. 4x plus 3 equals negative 5. Subtract the 3. 4x equals negative 8. Divide by 4. And x equals negative 2. So my solution is negative 2, 1. All right, next one. Again, when we look here, neither of our variables will immediately cancel out by adding or subtracting, so we're going to have to multiply either one or both of our equations. In this case, we're going to have to multiply both equations by something. So if we wanted to cancel out the x's, we would have to multiply the top by 3 and the second equation by 8, which is going to give us some pretty big numbers. So I think we should look at the y values. And in this situation, if we want to cancel out the y's, we have to multiply the top by 2 and the bottom by 3, which will give us less large numbers to work with. So multiplying the whole top equation by 2 and the bottom equation by 3 so that our y values will cancel. And that will give us 16x plus 6y equals 26. And 9x plus 6y equals 33. So now our y values will cancel only if we subtract because they're the same. So we need to subtract here. 16x minus 9x is 7x. Our y's cancel. And 26 minus 33 is negative 7. Divide by 7, x equals negative 1. And now we can go back to our original equations. So I'm going to use the first one again. 8x plus 3y equals 13. 8 times negative 1 plus 3y equals 13. Negative 8 plus 3y equals 13. Add 8. 3y equals 21. Divide by 3. And y equals 7. So my solution for these is negative 1, 7. Third example is a little bit easier because immediately you should be able to see that these will cancel if we add. So we don't even have to rewrite it. We can just put our plus sign. 4 plus negative 2 is 2. Negative 7 plus 1 is negative 6. Divide both sides by 2. Y equals negative 3. Substitute that into our original 5x plus 4y equals negative 7. 5x plus 4 times negative 3 equals negative 7. 5x minus 12 equals negative 7. Add that 12. 5x equals 5. Negative 7 plus 12. Divide by 5. X equals 1. Giving us a solution of 1, negative 3.